Okay, let's look at these future value problems. And the question or questions appear in that first framed block. It says, what interest rate is required if you plan on accumulating $10,000 10 years from now in an interest-bearing account by making 1,000 payments at the end of each year for the next 10 years? Okay, now I've also listed the formulas that get used, but I'm going to solve this one in Excel. Okay. Hopefully you see that if you put $1,000 away for 10 years and you only had 10,000 at the end of 10 years, you really didn't earn any interest at all. But let's go ahead and prove that using Excel. We have 10 periods. We're going to put away $1,000 each year. I'm going to enter that as a negative because we're giving up $1,000 over time. Remember that both financial calculators and Excel treat outflows as negative numbers and inflows as positive numbers. Okay, there's no present value, right? At this point, we're starting out with nothing, and in the future value, we have $10,000. Okay, so what we are solving for is the rate. And usually the variable that represents rate is just an I. And I will enter equal rate, hit my left parentheses here. Now I'll come up here and hit this formula editor. I'm not sure what this is really called, but that's what I call it. And we get these function arguments that show up, and then we can just reference where we put those. The number of periods was in cell, that's B15. The payment amount is the $1,000. It's an outflow. The present value is 0. We can make it 0 or leave it blank. Either would work. The future value is the $10,000 given in cell B18. And the type is a normal annuity. And I like to leave this blank, but you could make it a 0 because 0 or omitted will both work. And what we come back with is an interest rate, and I'll take that to a couple decimal points here, or maybe just one, equal to 0. So we've proved the answer there. Now, let's take a look at the next question. How can you calculate this rate? Well, we calculated the rate by using Excel. It's built into it. We could calculate it by using this formula here. Okay, and now that we know the rate, we could plug the rate in, work the formula, and come up with the $10,000. Without resorting to higher mathematics involving logarithms, other ways you could solve this is simply trial and error, or you could use tables. You could use the annuity factor tables, and again, it's a trial and error. You sort of see where do you get close to the $10,000 amount. But I prefer to use Excel, so that's all I'm going to illustrate for now. Okay, now the next question says, what interest rate would be required if you plan on accumulating 10,000 10 years from now in an interest-bearing account and you plan on putting 1,000 today and plan on making no additional payments? All right, well, what I'm going to do is I'm going to label this as case 1, and I'll underline that and maybe justify it. And then I'm going to copy all of that over, change this to case 2, and change what the various information we have would be to support case 2. And case 2 is the case where we're saying we're planning on accumulating 10,000 10 years from now in an interest-bearing account, and you plan on putting away 1,000 today. Okay, so 1,000 today goes here, but we're making no other payments. So I'll put we're giving up 1,000 here, and then this becomes 0 because there's no other payments. And you see that our formula becomes about 25.9. I mean, we could get more exact if you want, but I think 25.9 is close enough. And if I hit the F2 key, hit the function editor, we see it calculated the 0.259 or 25.9% using the new parameters that you see up there. Okay, and that's what I wanted to present today, illustrating these two cases. Now, keep in mind, since there's no payments in the second case, if you wanted to work this one by hand, you would use this formula here, okay, because there's no annuity payment. Thanks, everyone.